Dear audience, dear presenters, it's 9 o'clock and being Dutch, which is close to being German, I have to start on time, not only because of that, but also because the organization has asked me to do so. Very warm welcome to all of you physically here. To be honest, I've been participating in workshops years before in sustainable places where it was actually a meeting of the presenters, but now I see really actual live human beings in the audience, so that's very good. I do not know yet how it is online, but thank you already for joining this workshop. I will, and there I need my glasses, I will introduce, and I will keep it brief. I will introduce the presenters of today for this workshop, data management of enhancing the circular built environment, which in my opinion is a really, but I'm a bit biased of course, a really interesting topic, becoming more and more interesting. You see the more and more places, it's getting more and more impact. And therefore I'm very pleased that we have a really interesting lineup today of speakers. I will keep it brief because I want to save some time for the presentations itself. I think that's more interesting than my introduction. We will see some best practices today in several things. We are talking about tools, about roadmaps of solutions. Also, especially one project is focusing on the dissemination, because as we all know, it's good to do research, but if we are not exposing, if we are not disseminating it, we don't create impact either. So a lot of stuff about toolboxes, different use cases, also a circular potential information model, like a backbone, how we can organize this, and we will conclude this series of presentations by a very interesting presentation about how is something done really in practice. That will be done by Annie and Elma. And then, if we still have some time, we can answer some questions and have some discussions. And if then there's eventually some time, we can try to make some conclusions. So I mentioned already Annie and Elma, but before we will start with Adriana, José, Ines, Jaime, Sama, those will be the other presenters. But Adriana, if you can come to the desk or to the floor, whatever you prefer. Yeah? Okay.
No. Yes. So, good morning, everyone. It's a pleasure to be here today. I'm Adriana Salles. I'm from the Cost Action CircularB. It is the implementation of circular economy in the built environment. So a little bit in a nutshell, what is the aim of our action? So it's to define the methodology for developing a common circularity framework for inclusive application and assessment, and to new and existing buildings to support decision-making for all value chain stakeholders. This is the picture of our action. So we have representatives for more than 40 countries. Here are just the management committee countries, and also more than 400 members. And we published 2 books already, and there is one to publish soon. And we are structuring in 4 working groups, so about circular strategy and best practice. It's a working group 2, circular value chain and stakeholder engagement, and working group 3 in the KPIs framework, and 4, dissemination and results communication. So this is our big picture, let's say, how we are structured to have this circular framework. And now I will tell you what we've been researching about the state-of-the-art on digital tools for circular economy. So it will be more about the concepts of the digitalization and how this can drive this process to the circular transition, to the sustainable transition. So first, what is the main concept about digitalization? I think there is not one only concept, but we can think about the emerging and often interconnected digital technologies that will enable more efficient process and enhance traditional and new goods and services, products, and business models. So here we can have like this broad vision about digitalization. Also, the digitalization has been driven by these two technological trends, that is digitization and interconnection. And it's parting for the European plan or European future vision because the digital transition can open new opportunities for new business, for trustworthy technology, foster and open a democratic society, enable a vibrant and sustainable economy, fight climate change, and sustainable transition. And we identified like the key requirements for these three transitions, so towards a green and digital future. We can divide in these 5 main areas: social, technological, environmental, economic, and political. So we need this just transition. We need a social engagement. Also, we need it for innovative infrastructure, data availability, and security, reducing the impact of green digital technologies, new markets, the diversity of market players, and standards and policies. Also, another important concept are the key enabled technologies. So they are the technologies that have a broad application area and the potential to drive in economic growth and innovation. So they are the big umbrella of the technology. And they are divided for the European Commission in 3 main areas, like the production technologies, the digital technologies, and the cyber technologies. And they related these 6 key enabled technologies to the twin transitions. Also, the digitalization can amplify the circular transition once it challenges the prevailing business as usual and outlining new paths toward a more sustainable, circular, and digital future in the 3 domains of the sustainability: in social, economic, and environmental. In the construction sector, what's being found is that they are categorized in 3 main areas. The first one is the data acquisition by sensor, Internet of Things, 3D scanning, automating processes. The second one using the robotics, 3D printing, and drones. And the third one is the digital information and analysis with BIM, augmented reality, virtual reality, and digital twins. They also been adopted. They have different levels or 3 levels of adoption and forms of implementation. So the first, the basic one, is just to facilitate communication and reduce travel, like using WhatsApp or video conference. The second one is more improvement and automation of process of manufacturing. And the third one is the high level of usage digital tools. So when I have drones for 3D screen, 3D scanning, like printing, 3D printing with prototypes when I test a solution in the digital environment. Also, we found that the digital technologies, they have emerged like these vital enablers in closing, slowing, and narrow the materials looping. So they can help this dual transition to sustainability and circularity by analyzing, testing, and making informed decisions. We identified 14 main digital technologies that can be used to implement circular economy, or are the most used to implement circular economy. I'm not going in details in all the technologies here, but it's just what we found in our research. Also, the benefits, there are many benefits identified in the use of digital tools or digitalization in promoting circular economy. We can list some environmental benefits when they can have easy access to a product, material information through materials passports. Okay, I can analyze and test a solution and make decisions, use life cycle analysis. I can have more effective construction and demolition waste management. Also, under the social benefits, we identified that the use of digital tools can accelerate the economic and social progress, making more inclusive and livable places, cities, neighborhoods. Also, safety and comfort measures, and we can use it to reduce costs and have more affordable houses, a theme that we discussed yesterday. Also, through the economic benefits, we can use life cycle cost analysis. We can test and evaluation solutions before implementing. And also, we have opportunities for new business models and circular business models. Are we okay on the time? Yes?
2 more minutes.
Okay. So, and last we have managerial benefits. So we can facilitate this interaction. The use of digital technologies or digital tools, trust in this management and also this collaboration. So we can also use the data management and monitoring the materials flows. But also we have many barriers and challenges for this digitalization, especially because the construction site has many reluctance to adopt new technologies. So it's more slow than other sectors. And we can have the complexity of the building sector, the construction sector. We have different imbalances within the industry in adoption of new technologies. Also, the buildings and fragmentation of the construction sector. We have a lack of integration, interoperability, compatible database, standardization. This reluctance to adopt new technologies, also lack of expertise. And in resources challenges, we have the high implementation front costs. So throughout the life cycle, we have these many benefits, but the first phase has a high implementation, the lack of expertise, and also coordination in the strategies. But the enablers and the success factors for digitalization, we identified into these 3 domains. So we need collaboration and communication. So this shared vision and common interest among the stakeholders. Also, professional trainings. When we equip the workforce with skills to use and to adopt these new technologies or these digital tools, it's easier to implement. And also government incentives. We can also say industry collaboration, social engagement, and policy investments, incentives. So in summary, digitalization holds the immense potential to support this transition to a circular economy and a more sustainable built environment. Also, this transition necessitates the collaboration among different stakeholders, including manufacturers, suppliers, consumers, and the government, and demands a holistic approach to overcome the barriers and the challenges. So, thank you very much.
Thank you very much, not only for being in time, but also for this really nice overview. I can imagine that people might be having some questions, but I would like to ask you to hold them, because in the end, let's collect it all together and now keep the pace and also give the floor to the next presentation. Thank you very much.
Thank you.
José Luis.
with this.
The floor is yours.
Thank you, Andre. Thanks for the invitation to organize this. And yeah, my name is José Luis Gálvez, and I'm here to show you some aspects of what Adriana just mentioned. And one of the things in the circular economy is to keep track of things. So I'm here to present the DRASTIC project, the digital traceability solutions for disassembly and reuse, which is the main objective of the project. So what is, sorry, it's not working. DRASTIC stands for Demonstrating Real and Affordable Sustainable Building Solutions with Top-Level Whole Life Cycle Performance and Improved Circularity. But what remains is the word DRASTIC, and a lot of jokes come from that, but yeah, I have to deal with that. But at the end, it's a project where we want to demonstrate sustainable solutions on the field of reusing construction products. It's a project coordinated by Vito with 23 partners across 8 European countries. And some of them are main players. We have 5 demonstrators, which are companies like Saint-Gobain. We have also Timbeko from Estonia, Omtre in Norway. We have Celsa, steel makers in Spain, Weber in Germany, which are piloting. And the objectives of DRASTIC is really to show that environmental impact reduction is achievable, is actually affordable using these circular strategies. And for that, we aim to use 5 demonstrators, as I told you: Estonia, France, Germany, Norway, and Spain. We'll not go very deep on that. But at the end, we have different approaches to the same problem. And yeah, one of the main objectives is to really develop a new understanding of how, for instance, environmental performance is measured. So we are developing a multi-life cycle assessment platform or methodology where we could actually evaluate how the impact of a product that is reused several times during its lifetime can be measured. And that's one of the objectives. And the other one, of course, because we are talking in the era of digitalization, we need to keep track of things, and we need to implement a digital traceability platform. The main objectives for this platform is really to integrate these novel data-driven tools. Some of them are just existing, but some of them are not. And we are making a lot of emphasis on the way we are diagnosing these products. What is the health of the products we are going to reuse? And that is some information that has to be kept tracked. We are working also at building level, for instance, developing tools on the fast diagnosis of thermal efficiency. We are also, for the construction and reclaiming materials, we are developing automatic identification by artificial intelligence. We have a concept on extended traceability I will show you later on the involvement of the different actors in the supply chain for the reused materials. And of course, we have to implement this new methodology or the new approach for multi-life cycle assessment and multi-life cycle costing. And also focusing on circularity and sufficiency indicators. At the right, you can see how everything is integrated for the moment. So basically, what we want really to keep track is of the product that we are reclaiming. That's our starting point, and how that's integrated. And for that, we have role players like, main players like Madaster or Kala to perform all these calculations. But we have to first generate information. And for that information, one of the main requirements we are defining now is, okay, we have a digital product passport that has to be defined, and we are incorporating those concepts. But when you evaluate what they're asking for that, even though there is still some definition to be done on that front, we still need to be more ambitious if we want to go to reuse construction materials. So this is the one of the things. It was animated, so I didn't want to put everything just like that, but it's okay. Sometimes these things happen. one of the first objectives of what should we do in extra in DRASTIC is really to find out what the demonstrator, what the companies, what the people implementing the solution really want. And these are the fields we can summarize a bit. Yeah, they want accurate diagnosis. Every company has different understanding of how diagnosis has to be performed, but all of them agree that it has to be there, because there are other processes on traceability that will require this information to be done. And we need to know, for instance, how can we standardize this approach to traceability in the way that we may want data by batches, we want data individual elements. That's a key aspect, for instance, when you want to reuse steel. If you do test one by one, the cost is unaffordable. So there is a big issue, and probably you are all aware that we need risk and insurance coverage for these elements, and that is not easy to achieve. And of course, they are very much interested in product history and management. They really want to know what happened with the building and with the element we are going to reuse. For instance, for a steel beam, you really need to know how was the load bearing, of where its position in the building was, or what are the functions, or what are the loads that had to happen during its life. For the rest, for the four last, they are very related to the first one. That's why it was animated. But one of the things that some of the demonstrators really highlight is that there is a lack of harmonization and standardization. They don't know what to do. Some countries, they propose routes. They can use those, but there is no real overarching structure to how to handle this problem. As I said, we need a standardized approach to traceability, but at the same time they said we need also to be flexible, because they want really, they are big companies sometimes, they keep already track, they have their own traceability system, so the systems we are developing, the digital passports, for instance, they have to be flexible to adapt to their internal systems. There are some practical aspects of reusing building parts, of course, and especially when we are working at modular construction, that's, and on-site diagnosis, because there is a large level of expertise in people from the company. But if the most expensive people in the company has to do the tracking of all the quality requirements, one of the problems we will have is that the cost and time to do the assessment is too much. So we need some kind of automated tool, artificial intelligence, to increase affordability of the approach. This is, I don't think you can see anything. Something happened. Okay.
It's delaying a bit. But
It's really?
you have 2 more minutes.
Okay. No, I mean, it's just that my figure doesn't show in the screen. Yeah, it's okay. On the right, what you cannot see is the scheme of information integration into the product traceability file. Yeah, but there were letters. Okay. That doesn't matter. So basically, we have 4 fields of file of information requirements. We have the Smart City marking and the declaration of performance. We have the new requirements for the digital passport. We have EPDs, because most of the products will have EPDs. And on the left corner, it was drastic requirements, where we go beyond on circularity indicators and diagnosis information. So this is a model, and on the left you can see this is the process we are going to go with the data model we have developed. So basically we develop the structure and go back to the demonstrators to validate information and how can be integrated into the supply chain. So just as a conclusion, the project just wants to provide a comprehensive digital platform, but of course, when we're talking about reused elements, you have to have some flexibility and very flexible approach for the traceability and the quality performance of elements. I think it is important to highlight that at some point we need AI to really increase the affordability of the solutions. And we need novel methods to measure how the system performs. So we are proposing something in DRASTIC, but it's just a framework of analysis for multi-life cycle. And the project is already 1 year now. We have developed these requirements, and now we are starting to implement them in the real demonstrators and to see how this will work. So that's all from me. Thank you very much.
Thank you. I do not know if I'm allowed to share this, José Luis, but he asked me beforehand, please be very strict to me especially, but you did it very well, exactly on time, man.
Just because you look angry.
Ines, can I invite you?
Yes.
The floor is yours.
Thank you, André. So, hi everyone, I am Ines Cain. I am the Dissemination, Exploitation and Communication Manager of the Samfori project, which stands for... Do I have to click here?
Sure, yeah. Or you can use the mouse, and we're 100% sure.
I'll do that.
Slight delay, what is he online?
Okay. So the Samfori stands for Creating Material Banks from Digital Urban Mining. The speaker that was scheduled for today unfortunately could not come, so I am filling in for them. I am not a data management specialist, but I do have 5 minutes to present to you the project today, and I hope that this could result afterwards in collaborations between our projects. So our goal with Samfori is to create material banks from the built environment using innovative technology to make construction more sustainable. So let's dive into how we plan to do this. To find ways to reuse materials from buildings, the core of Samfori's work is about 3 main things. Firstly, tracking where building materials come from and where they go, so develop a traceability system for building materials. We also aim to create a system that helps figure out how these materials can be reused by creating a holistic framework for circular use of construction products. Also, we plan on developing smart digital solutions for material identification and property analysis. So digital solutions and interfaces will be developed to ensure a connection between Samfori and platforms developed in previous existing EU projects. Yes, so this includes software and databases powered by artificial intelligence, blockchain technology, to ensure everything is tracked efficiently. Our tools will also focus on reducing waste and lowering CO2 emissions and consider circular economy practices such as reduce, reuse, repair, recycle, and renovate. Additionally, we'll improve existing tools, for example, by enhancing the BIM standards to support the circular economy and make sure everything works well with other systems already in place. Samfori will develop a new circular BIM, a CBIM, that will also be connected to different national construction material databases, including other digital material passports. So to sum up, the objective of the project is combining urban mining and digital technologies for automated data acquisition and building materials identification. The project, well, of course, is funded by the European Union and includes 17 partners from 9 countries. It started in June 2024, so it's very, very recent, and it will last 42 months. Samfori's results will be demonstrated in 3 different pilot sites. In Norway, in the Netherlands, in Spain, and we'll consider existing buildings with different uses and typologies, and targeting different products and materials to validate the methodology. We're also planning to train workers in the construction industry on how to use the new tools and methods so they can apply them in their everyday work and help bring Sunfury's vision to life. So in conclusion, Sunfury aims to support the transition to a circular economy by pioneering new methods for material identification, circularity, and sustainable construction. And my question is, because all of our projects will be working on very similar topics, how can we create synergies between them, and how can our projects work together, learn from each other, and perhaps you have ideas of collaborative activities that we could do together. So yeah, this is my very large, very vast question. So I'll let you think about it. Thank you.
Thank you very much. Well done. It's such a short time span. But as you said, it's good to already raise some questions. Two ways, because we're going to stay a bit longer, of course, today, tonight, tomorrow. So please, after this workshop, let's get in contact about these topics as well. Jaime, could you please come forward?
Yes.
This one, right?
Yes, the previous one.
Yeah.
We are not sharing the screen, I think. No. Okay. Hello, everyone. So thank you for the invitation, and it's a pleasure to see so many people. My name is Jaime Moreno. I'm from Tecnalia, and I will talk about the LIAISON project. So this project deals about different digital and physical developments in order to improve the sustainability in transport infrastructure in this case. So I will start with a quick video, if it works, in order to have an overview of the project.
With more than 136,000 kilometres of roads and 234,000 kilometres of railways, Europe has one of the largest transport networks in the world, with a very high environmental impact throughout its life cycle. For instance, in 2020, millions of tons of aggregates, cement, asphalt and bitumen were used in order to maintain and develop this network. Moreover, road transport is responsible of a third of the total final energy consumed and the CO2 generated in the EU. Our roads and railways are evolving towards more sustainable and low-carbon transport. Through 5 demo sites in Spain, Italy, Poland and Slovenia, and a governance tool, the LIAISON project will give a twist to the EU goal of having a 100% renewable transportation system by 2050. The LIAISON governance framework will support this endeavour, along with the latest circular technologies, sustainable beams, improved ballast, bio-asphalt, an automated system for lighting and damage detection. These pioneering technologies will shape the future of road and rail networks in Europe. Welcome to a new era of transportation infrastructure, where sustainability and innovation converge for a brighter tomorrow. LIAISON, making transport infrastructure climate neutral, sustainable, and circular.
Okay, so as you can see, the project deals with a lot of different solutions, physical and digital. And I will present 2 of the digital solutions that we are now developing. So the project started 1 year ago, and now we are finishing some of the solution. The first one is a dynamic multi-infrastructure governance framework. So what is the idea here? We are asking to the construction company to adopt different new solutions for improving the sustainability in the civil works. But we don't have the reference of what is sustainable and what is not sustainable. So the idea here is to implement a methodology, a complex and advanced methodology, in order to assess the sustainability of the civil work, the transport infrastructure, compared with the business as usual, no? With a standard approach. So here we assess the different dimensions of the sustainability. We assign different weight and score to the different solution, and we arrive with a multi-criteria analysis to weight and to have a score and rank of the different solution that we are implementing. So this is aimed to the design companies, for the construction companies, and for the administration, in order to, in the tendering process, to have an overview of what is sustainable and what is not, in order to select the most sustainable works. No? And the other tool is a BIM-based tool for enhance the circular economy at the end of life of the project. No? In this case, we are implementing a digital model that help us to estimate the amount of waste that we will generate during the maintenance or the demolition of the civil works. So with this BIM-based tool, we are able to estimate the different materials, the different waste that we will obtain. We are able to plan the decommission and the valorization of the different waste. And the idea is to implement a layer of traceability, no, with blockchain technologies and other technologies in order to track the materials from the demolition to the valorization plant, and after that, in the inclusion of the waste, the valorized waste in new product. And well, now we are finishing the different tools, and the idea is to demonstrate it in a real demonstration project. So here the idea is to assess the different maintenance option during the expansion of a motorway in the north of Spain. And well, here we are helping the administration to tender the maintenance works of this motorway. And that's all from my side. Thank you so much.
Thank you. I'd like to thank you twice for the presentation and a very nice movie. Sama, please continue.
Perfect. So, good morning, everyone. It's actually really nice to see that the room is full, and maybe I can do some dissemination on behalf of R2M, if I may. So I heard that this year they had the highest in-person registration, and I can see already that the room is full, so that's really nice. My name is Sama. I'm from Demo Consultants, sitting next to the director of the company, and I'm happy that today I'm presenting REINCARNATE project on behalf of the whole consortium, sharing with you some of the recent results that we have in the project. So I'm not going too much into details introducing the project, but just in a nutshell, reincarnation of the construction products and material to extend their lifetime and basically bring them back to life is the concept of the project, and hence, in short, we call it REINCARNATE. The project started in 2022. It's research and innovation action scheme, and we are quite far in the project. We have passed the half of the project, and I'm happy that today I can present some results too. We will have 2 more presentations in Sustainable Places about the project. So if you're curious about the project, then I invite you to join those sessions as well. Here, I would like to talk about the core aspects of the REINCARNATE mission. So the first one is the CPIM platform, and you all know that in these projects, we all like abbreviations, right? So CPIM stands for Circular Potential Information Management. And this platform is very fundamental in the project. So basically, a lot of things are coming into this platform, which I will explain later on a little bit more about it. Then we have 10 unique innovations that they will enhance the functionality of the platform. So either directly or indirectly, they are related to the platform, and they support some of the aspects in relation to circularity. And of course, to showcase the impact, we have pilots, as it is very common to have in these projects. So when we were discussing with Carola about this session, we discussed that it's good to focus on data management for enhanced circularity. And so far, you have seen projects that they were all related, and they are more or less, if I'm not mistaken, at the beginning, right? So we saw that it's really good to share some ideas together, but then with the last two presentations going a little bit deeper to some results, specific results. So that's why in my presentation, I will focus mainly on our platform because it's very much related to the concept of this session, which is data management. So as you can see in this slide, basically, theoretically, this is how CPIM can support the circularity. The framework that you see basically supports different aspects from hindsight, foresight, and insight, and this is how the 10 innovations that I mentioned earlier are connected to the platform. So the main purpose of the platform to collect, organize, and disclose information. I think most of you are familiar with this scheme. Nevertheless, I thought that it's good to just reiterate on that, how data becomes the wisdom, right? So this is like a pyramid of knowledge management. So we all know that we have data, but basically there are raw symbols, and then we have information, and in this stage we try to basically transform data in usable format, right? And then just extract some patterns. So they are very descriptive, and they describe how things are performing. And then we have the next stage, which is more predictive. So we try to ask questions like how, and then that becomes to more like knowledge. And then we have the last step, that if we put everything into context, then we are able to basically make a strategic planning and make a strategic decision making. And as you can see, our innovations are also covering these different aspects. When we talk about knowledge management, I think it's also good to talk about knowledge representation. And you might think that these are very theoretical, but bear with me because I'm trying to also show some practical implementation of this. So when we talk about knowledge representation, and specifically how it is described by SWA, we have 3 pillars: logic, ontology, and computation. So basically, ontology defines the being of the entities. What do they mean? And how do they relate with each other, right? And then the logic provides the formal structure where you can do some inference. So basically, with some rules, you might be able to navigate the ontology that you have. And with computation, you can implement them, so you can make it machine readable. I talk a little bit about ontology because I like this phrase that it says that the road to hell is paved with good intentions, right? So within the construction industry, we all have good intentions to make things right and to do the right thing. But what we have identified in this project is that as one of the barriers, there's a lack of consensus between different stakeholders. And when there's a lack of consensus, that can result to miscommunication, right? So we, since the beginning of the project, we realized that it's very important to define the ontology. What is the ontology for circular economy? What does it mean? And basically, the ontology is a formal, explicit specification of the shared conceptualization. So in a nutshell, as I said, there are terms, there are concepts, but it's not very clear between different stakeholders, and the whole purpose is to define that and define explicit connections between them and the relations between them. So what we did in this project at the beginning, we tried to identify the key notions. How did we do that? We came up with structured templates, we did workshops, and we are now in the process of actually writing a paper about this, because then we can propose that as a generic and general methodology, so it can be implemented in other projects. But what we tried was that we had a diversity of different stakeholders in the project. So through these templates, we try to understand what is the key notion. So for example, as a contractor, I find this important because I want to achieve this, to create this and that. So once we did that, interestingly enough, we found out that there are some common entities, some common concepts within all these descriptions that we found from the different stakeholders. So there are always actors involved. There is product component, there is energy, there is value, there is information and process. But so far I haven't described the relation between them, but what we understood is that when we talk about circularity, it's basically a process in which different actors are trying to create value. And that value could be economic, could be social, right? So that's something that you can also define under value. And as you can see here, then you define the relations between different concepts. So a process involves actor, and then a process as property, it has cost, it has environmental impact, it gets one input, maybe it's a product, or maybe a component, and then it creates another product, right? And then the product has life cycle, the product has elements, et cetera, et cetera. So you can go deeper and deeper in this description. And as I said, I don't want only talk about theories, right? And I want to show how we did this in practice. And we actually so far have implemented this methodology for 2 use cases: upcycling flat glass. So basically, it means that you use flat glass like this one also in the next life cycle as flat glass. So it's quite valuable, not downcycling it to bottles, for example. And the other one is the digital delivery ticket. Since I had limited time, I only focus on one, but if you're interested, I can also later on explain about the other one. Am I good on time? Yeah? Okay. So what we did, and this is one of the results of the workshop that we did, we tried to understand what is the process. So what are the steps involved? What are the different actors involved? And as you can see, in a very, very abstract term, you have a window in the facade, then the window is dismantled, then it's in the crushing center, then it is called cullet when it's crushed, then it goes to optical sorter, and then flat glass is manufactured again, and then it's in the building. So this is more or less the big picture, and then for each step we have process, we have actor, we have input, and we have output. Basically the data flow. Then we started to define the taxonomy based on the notions that we identified earlier. So for this specific use case, what are the process? What is the information required? What kind of value it generates? What are the products? What does it get as an input, and what does it produce as an output? Then we try to also go deeper into the actors and see how they relate with each other. And then we started to sketch that in the CPIM, the Circular Potential Information Management, that if you have a platform, then who are the actors, specifically in this case, who are involved? What do they need from the platform? And basically, what are the products? And then what are the processes that I explained earlier, so you can see on the you can see below, and what are the tasks? And then when we draw this scheme together with people who are expert in this field, and they are part of the project, we identify that actually getting input from the window is one of the bottlenecks. So you can see actually here that this is very important, because then every process requires different batch of that data. So what we did, and this is coming back again to the ontology, is that we looked at the existing ontologies, and we didn't want to invent the wheel. And you all know that IFC is already a very recognized data format. So de facto is actually the data format and data model, which is used in the construction industry. Sorry. And we thought that it is good to utilize that and do not invent a new thing. And then if we recognize that something is missing, we can actually propose that. So this is an example where you can see that a building has elements, window being one of those elements, and window has different entities. This is how it is basically modeled in IFC. So what we did together with this expert, we went through all the common properties which are already identified in IFC. And then they told us what is actually important for them, what do they need. And we highlighted all those parameters, and together with them, we highlighted the missing parts. That's the part that we came up with the suggestions and recommendation, which I think it could be interesting for building a smart, because then they can maybe include it in the next round of development. So for example, we here propose 3 new properties. We define the type, we define the data type with the description that why they are important. And we also propose how they can be integrated. Then going back to the scheme that I showed earlier, I said we need ontology, but we need also logic. So we need rules of inference. So now we have this IFC file, we have the data stored in it, what to do with it. Then we started to brainstorm with these experts, and then we understood that we got an insight how actually they make their decision-making processes. And then we defined a few rules. So simple one, like if there is wired glass, then it has to go to landfill. If there is a film on the glass, and if the thickness is less than this, then it can go to recycling, and if it is laminated, it should go to downcycling. So basically, these are some decision-making processes that they have, and we have identified for each decision process what is the kind of data that they require. So here it comes to the computation part, as I said, so how to implement it, how to make it machine-readable, and actually how to use it. What you see here is a screenshot from the CPIM platform, which is based on RE-Suite platform, which is our own product, developed in-house, and MainFlux product, which covers the IoT part. So this is an scheme from what we have implemented, so all the theoretical part that I explained. So you have the IFC file. The IFC is modeled based on our ontology, what we have described. The data is there, and we have defined an interface where the users can do their queries, like those rules that I explained earlier. And then quickly you can get a dashboard. So basically you can understand what is, for example, the carbon footprint of your building. And of course, you can also scale this up and imagine that then you can do it with several buildings. So basically you can quickly understand what is the total volume or square meter of the potentials that you have within this neighborhood, for example. I think I'm almost reaching the end. So this is the end of the presentation, but as I said, we did the same process for digital delivery ticket, and that one is mainly about enriching IFC file with, you showed this QR code like that you can scan, so what we have done is that we enrich the IFC file with the data that we get from the QR code. Yeah, I'm happy to talk about it later on if you're interested. Yeah, thank you.
Thank you very much, Sama. And of course, I was a bit biased because I'm working on this project as well, but I learned a lot, to be honest, as well today about the project. So thank you for that, Sama. Like I explained in the beginning, we had 6 presentations. So Annie and Elma, you're going to give a duo presentation, if I'm correct. And I think also the sequence of all these presentations, I think it's very nice to end up with a concrete case that you're going to explain. So please come forward. Let me see, which one is it, Elma?
Okay. I think that probably with.
I will shift. But where is your?
Would you like some?
It's not here yet.
Oh, there we are. Oh, yes.
There you go.
Thank you. Okay, thank you. So we'll have a dual presentation and talk about our region project, where we are working on urban mining level and trying to integrate a couple of aspects which decision makers on a planning level are dealing with. On one hand side, we have material circularity and what we have, and material banks in the cities and the regions. On the other hand, energy aspects. And LIST has developed a very smart table where the idea is to bring a couple of different aspects together: materials, the circularity, energy, social, and help decision makers on a digital table make decisions, informed decisions based on the tools that we are bringing in. I will be talking about reversible BIM, which is, let me just go to another slide, which is one of the tools that we are bringing into the table, and is basically looking into the reuse potential of materials in a building. It is a model which basically tries to understand how easy you can recover material out of the building without damaging it, and understanding the reuse options that materials would have once they are recovered. In the end, this is the end picture, and I'll explain a bit more about the methodology behind in the next slides. In the end, you do get different outputs. One of these outputs is this kind of color-coded view on your building. The colors representing the reuse options materials have. The green ones would say that the direct reuse with minor repair is an optional. The red ones would mean that there is some asbestos and hazardous materials in there. Less red would be like recycling, downcycling, and upcycling, bit what I saw just here in a few slides before. And then the reuse by major repair going up to the direct reuse. Now, this reversible BIM is part of a bigger reversible building design toolkit, which has been validating during the Buildings as Material Banks project, Horizon project, ended in 2019, where basically I developed a whole toolkit which was based on the project and my PhD from Delft, end of last century and beginning of this century, which was dealing with design for disassembly, and ended up in a number of European projects. And I could say that the Buildings as Material Banks project, Horizon project, was one of the first ones where we tried to define the framework for circular buildings in Europe. So this toolkit tried to understand better what circular building would be, where we have developed two key parameters, how to assess circularity of building. One is the technical reversibility of building, that's the reuse potential of materials, what can we do with them, and the other one is spatial reversibility of building, which has to do also with adaptive reuse, what kind of different aspects and functionalities buildings could have in order to reuse them again. Together, there are design guidelines to support designers to design such buildings, but also assessment tools as a reversible BIM and the transformation capacity. I will not be talking about that one. Much of this is integrated in a number of, I think, ICO standards and things you've seen in the past, and circular economy principles published by European Commission, where the principles that I will be shortly talking about built into reversible BIM are integrated in levels and so forth. Now, going back to the bit of methodology behind the reversible BIM and how we assess reuse potential of materials, looking into this, how easy can we take material out without damaging. And in order to understand that, we have to understand how the configuration of the product or a building is set up, and what kind of dependencies materials have within a building. So a long time ago, it was really last century, I understood that there are three dependencies that we need to look at when thinking about the dependencies of materials in the structures. That's functional dependency, technical dependency, and the physical dependency. In the end, that's structured in these 8 key indicators, which are used to assess reuse potential of the building. The functional decomposition, just to go through some of them, the modularity of prefabrication level, whether there is a base element or intermediary between the parts or not, the hierarchical structure and hierarchy of the configuration, how easy can you reach something through assembly or disassembly process, the geometry of connection, the type of connection, life cycle coordination, just to name some of them. In the end, there are 8 indicators and 17 sub-indicators, which tell us how easy we can take a material out of the building and what is the level of damage of this material and what potential reuse option of the material would be. There's the reuse potential number becomes then a kind of number from 0,1 to 0,9, reflecting reuse options which are color-coded, as I showed in the first slide. And these reuse options basically are addressing the size of the feedback loop of the material when recovering material. The shorter feedback loop we get, the better or low environmental impact there will be and a lower economic impact. So what these loops represent here, they represent all possible options of taking material back into or making a new material out of the existing one. If we recycle concrete, then we will go into make a very big loop going to this red part where we have to crush a concrete. That means there is a lot of transportation from construction site to the facility where the recycling will take place. We have to create a new product and go through all production processes in order to create a new material. So that's very big feedback loop. Very short, the green one, short feedback loop would be if we would take a frame out of the building, repair it, or a steel, a beam, make some reparation, and bring it back into the new construction. So that's kind of a small, short feedback loop. How we identify which feedback loop we are dealing with is based on the indicators, 8 indicators and 17 sub-indicators I was mentioning. Of course, all these indicators, sub-indicators are published many times, and I'm sure you can find them also in articles or on the website. Before having these BIM possibilities, I've been working in this field for a long time, so I had to do this analysis manually, and this is how the manual analysis looked like, trying to understand the dependencies between materials in a building. So what you see here is a functional decomposition matrix and technical decomposition matrix of a building, where the functions are put in vertical columns, and the horizontal columns represent assembly sequences when these materials are assembled, and then the relations that these materials create between each other, representing also functional relations. If we have more horizontal, that means there are relations between functions, and also the type of each relation is being analyzed. Now, finally, computation get up, and it was possible to digitalize this whole process. And this was the first starting point. So this is how reversible BIM emerged, which helped to bring automated assessment of all these relations in a building, also the connections that these relations have, and help us analyze assembly and disassembly sequences. I did add to the BIM the CO2 material list from ICE material list, and the technical life cycle information from the Dutch technical life cycle database. Now I go to the pilot that we are working on in the region, and Anna is going to show what we've done further on with these data. So we have a neighborhood in Milan, a couple of housing blocks which need to be demolished. We've done first some manual analysis of the block itself. Then the scanning of the building has been done, the 3D scanning. And after that, and getting some technical information from the city of Milan, the BIM model has been built with the materials assigned, the connections between materials identified, and the analysis of all relations between materials in this model are automatically calculated. Identifying, this is analysis of one apartment in this block, which has 124 elements, so many relations between the elements, and these 7 disassembly procedures. This is very small, those are very small letters. I'm sure you can't read them, but this is just an overview of data that comes out of a BIM, telling us something about the function of material, the volume of materials, the embodied CO2, but also avoided CO2, which is related to the reuse potential score. Also the tonnages, that material, embodied tonnage of material, and reuse, potentially reused tonnages, again related to the material, to the reuse potential score. There's also an overview of all materials and the connections. As you will see, this material has 3 connections and the type of connections. So for the deconstruction companies to understand better how they can reach material, what kind of connections are assigned, and how they can plan the construction and recovery of the materials themselves. In the end, there is also a high-level understanding of what the capacity and circularity capacity of the Milan apartment is. And in this case, this is a building from 70s, which on the tonnage side and material side would have 3% of materials to be reused, and 97 to 98% of materials are going down to the recycling. And on the whole floor level, we looked also into CO2, where 16% of materials in this building have potential to be directly reused, and this 16% of CO2 can be reused, and 3% can be reused by reparation. There are some number of projects that we've done also through different European projects using this model. There's also circularity profile, which tells us about the circularity profile of building when looking into reuse potential of buildings. And obviously this one in Milan would end up in a low circularity profile because only 3% of materials could be reused. We also suggested potential look into innovative deconstruction technologies, and this is an example of the construction project in south of the Netherlands, where we have cut concrete parts of a housing block from 70s into 3D units and built new houses out of these concrete cores. And if this innovative cutting technology would be used, then this building would end up in a higher circularity profile. This is where we are now, and we are talking with Milan at this moment in order to understand better whether they would be able to maybe do some innovative deconstruction techniques or do something more than just crashing concrete down into the pieces and ending up in a circularity profile 0. So I'll give the floor now to Annie.
So we will continue now, as we know very well everything about the reversible BIM model. We can continue with the DDC platform because this is the next step in the region project. This platform, which is called DDC, it's the result of another project, which was the Interreg Northwest Europe project, Digital Deconstruction, which ended last year in September. So what's this platform? Yeah. Okay, so this platform is composed of 4 technical modules. So first we have a 3D scan of the building. Then we have the reversible BIM technology. Then based on the BIM, we can extract information regarding the materials inventory. And Block Materials, which was a partner of the previous project, was responsible for creating a material passport based on the blockchain technology. And then at least we were responsible to create a connection between the information we collected from these different technical modules. The idea was to create a decision support interface for construction and reuse strategy, combining different kinds of visualization. So we had visualization regarding BIM, indicators, economic and sustainable indicators, materials data, materials passport, And also the idea was to support the scenario analysis regarding the reuse strategy. Well, so this is a short video of the platform. Is it working? It seems. So we can see that here we have the detailed information regarding the building. We can have the location of the building, information regarding the documentation. Then we have an access to the 3D scan, which is also very important to have information regarding the context of the building component that we plan to reuse in other design. Then we have the BIM, and we have this inventory which is created directly from the BIM model. And we have this connection. Each line in the materials inventory, we can have a direct access to the building information modeling, but also we have this information regarding reuse potential. So here it's green, it means that we have a high reuse potential. Then we have detailed information regarding this material or component, actually. And the idea is also to use filters to encourage people to understand the reuse potential, but also to define reuse strategy. So we can create filters, and we can combine these filters to have the good visualization to support the collective process regarding this reuse strategy. So this is the results of the filtering. And then we have this dashboard with which summarizes the data regarding the composition of the building and also the reuse strategy. Well, so in the region project, the plan is to use this DDC platform, but we are, as you have seen, at the level of the building. The idea is to combine this collection, this data collection regarding the building, and to extrapolate the data to have this data at the urban scale, so to combine GIS system, BIM, material cadastre information, and also materials availability. The idea is at the end to provide support to match the supply and demand, and also to increase the reuse of materials coming from the construction. So for the case study, we have a case study in Beckrich, also in Milan, but for this demo, we will be in Beckrich, which is a very small town here in Luxembourg. And the idea is to use also the MUST system, which is a system dedicated to citizens' engagement, and which also use geospatial data for visualization. So we have a demo, so I encourage you to go to the list booth to have more information regarding this MUST application. So considering the case study in Beckrich, we have the Beckrich demo. So the idea is to have this table in a neighborhood regeneration office, and to add in this table a lot of information regarding the digital twin and the urban mining. So we combine 3D scan inventories, BIM modeling, and then the idea is to identify building typologies and to have this large information at the level of the city, and then to encourage citizens to create scenarios regarding circularity. So what we have at the moment, so the project started this year in January, so we are just at the beginning regarding the prototype, but we have this map server with a lot of layers of information. We have the information regarding the construction date of the building, the cadastres, and we started with simulated information and data regarding materials composing the building. So let's see the short video if it works. Yeah, it works. So here is the table. So we have this token. So we use the token to zoom in on the map, and then we can actually place a token. So you can see different information, different layers. So here we have the information regarding concrete, slate, wood, steel. And when we place the token, we have this visualization regarding the building we have previously selected. So if we click, we can see the different composition. So we are just at the beginning, so that's not real data for the moment. The idea is to create this typology. So as we are at the beginning, we have a lot of next step, actually. So the next step is to scan and to create the airbeam for the Beckrich pilot site, then to define these typologies regarding this building, then to develop CE, circular economy functionalities regarding this most application for the citizen engagement, and created also the connection with the previous asset regarding this DDC platform. Then we want to deploy, of course, this platform on the pilot case in Milano and also in Beckrich, and to test it with end user, and to also measure a lot of indicators, and also to compare with the baseline. So at the moment we are also in a very interesting period of time where we are defining the indicators and also trying to collect the information for defining this baseline, and then of course to analyze the impact of the circular economy intervention on these two pilots. So that's the end for me. Thank you.
Thank you. Thank you very much, both Annie and Elma. To be honest, we are on time, so we even have time for you if you badly want to take it to tell a joke or something. There is time.
Yeah, really?
Yeah? Feel free. Feel free. But to add on that, the recommended. I did not know that there was a demonstration of the MUST table available. I had the privilege to see it earlier this year at the Liste venue. If you have some time, please go there. It's really interesting to see how it's working. It's user intuitive. It's inspiring. I would call it even playful, but it's really professional and contributing. So if you do have some time, I would recommend to visit that one. We have seen quite some interesting presentations, in my opinion. And I'm not concluding yet, but I want to give the opportunity to the floor if there's any burning questions. I tried the online audience. There were no questions in the chat, so that does mean that either it was crystal clear or nobody is there. I don't know, but that provides another benefit for you. There is time here now to have some questions. Who has? The gent over there.
Thank you very much. Francesco Malandrino from CNR. I should say that I work in the telecommunications domain, so I missed many of the things that you mentioned. I've learned many others. That was fascinating. I did hear mentioned a couple of times in a couple of different projects blockchain to keep track of all this data and so on. So my question is, why do you need blockchain? In the sense that blockchain is kind of inefficient, and you accept that if there is no central authority, like a Bitcoin-like scenario. So are you in that scenario, or I mean, why are you bothering with blockchain?
Who wants to address this? It was in one of your presentations. I can give my personal opinion, but they're the experts, so... Go ahead. Yeah.
Thank you. Actually, it's a good question, but it's a technology. We can employ other technologies for the traceability. It's not the only one. So for the management of data, when we employ blockchain, I'm not expert in blockchain, of course, but well, the way to decentralize all the information, I think, is good for this sector.
Yes, I mean, I guess. Sorry, actually, first.
Yeah, just from the point of view of digital deconstruction platform, why we included blockchain is that we see that we need lots of data from industry, from manufacturers, information about the materials, how they are produced, the recipes, and so forth. And many of them tend to say it's a secret, and so forth. So we were thinking the blockchain would help to secure the data, so that only the one person, so you give permission to someone to look into your data. You lock it, so that's why we thought blockchain could help to get all the data we need from the industry, and they are reluctant to share the information just like that.
Anyone else?
Just one minor
Sure.
thing. In DRASTIC, we are working with reused materials, and one of the things we're thinking about is counterfeiting, because there will be, if you generate product traceability files where you store all the information, how secure is that data, where it is coming from, and I'm sure that this reuse element, which has a very low carbon footprint, how can we rely on the information? And blockchain is one of the technologies. It's just one option, but it's actually there, and we can use it. Yeah.
To see that mentioned multiple times, so I was wondering whether there was something special about it.
It is a special.
Since the ice is broken, who wants to follow?
Hi, Tanya Volkanova from CoBuilder. So one of my questions is material passports and how do they relate to the concept of DPPs as described in the ESPR, and one specifically for the DRASTIC project, you mentioned the smart CE marking. Can you shed a bit more light on how does it correspond? What do you do there?
Yeah, the difficult question for me, right? No, you're right. We are going to, I mean, when we talk about traceability, I use the word product traceability file because I don't want to say digital passport, because the digital passport is not defined yet. We don't know yet what is going to happen, but we can say like it is a prototype of the passport, but it's actually a data accumulator that we want to keep track of, okay? And in terms of the relationship with the material passport, it's just depending on the perspective who defines what, but basically we are working with Madaste, they're talking all the time about material passports, and in other projects we are talking about digital passports, but for me, from my point of view, they are equivalent, because it's from the traceability point of view, it's not my point of view, but it's basically from the traceability point of view, they are both important to keep track what is happening to the materials, pre-installation and after installation, what is going to happen during the lifetime. Smart CE marking, that's a very, very good question, because we have now a development of the digital passport. They're going to be standards. There are standards already there. And you know that the smart CE marking is based on a data structure, which is actually meant to be easy to store information related to the CE marking and the declaration of performance. Now we have new requirements on the declaration of performance, where this data structure seems to be kind of easy to use. And of course, it goes deeper on the harmonization needed at the digital passport. That's why we are proposing not only smart CE marking, but other standards like the 22057, which is for EPD incorporation into this kind of the same data structure that we can use actually to track all the information. So that's why, that's the main reason. It's not that we like it or not, it's like because it's an easy way, which is already there and we can use.
Aan de back.
Thanks. Huub Keijsers from TNO, the Netherlands, also part of Building Smart Benelux. So actually I was very glad to see, I think I have seen most of the presentations. I only missed it in once, so I hope it's in there as well.
Was that because you fell asleep or you entered later?
I probably didn't fall asleep, but I was, well. Anyway, so my question is, could you define as a group of different projects, define 3 or maybe 5 attributes which you would really like to have in IFC, so you can at least interface between the different projects and then build upon a larger European community? So if there are the 3, somebody mentioned 3, but maybe the other ones need 2 more, please give them to Building Smart Benelux, but also to the European platform, because we really would like to put emphasis on that one. So are there 3 or 5 you can define? And if not today, I'm here also tomorrow. So thanks.
Okay, thanks.
Who wants to
react, Sama?
Thank you very much. I'm actually really glad that you're here. So you brought this up. And I think that's really a good point, because we are also looking for synergies between different projects. So I think that could be really a good exercise. And I have been in contact with another project. It's not present today here with us, but they have also used IFC, and they have looked into IFC, and they have also identified what is missing and what could be added. So I think IFC, at least that's my opinion, working in REINCARNATE project, could be really a good starting point, because we already have a lot there. So we don't need, as I said, to invent the wheel again. And you mentioned about 3, but I think that could be a good exercise to maybe define different categories, and for each categories, maybe we can come up with the most rated one. Because we also don't want to make it too data intensive, because then people cannot provide the data. Because one of the challenges that we have faced is that, okay, it's cool, you have defined all the data requirements, but who is providing the data? How do you get the data? So that's completely another question. And often you see that in many even circular potential indicators, they require the user to provide so many data that at the end it's so expensive time-wise, that they just don't do it. So our question is also how we can simplify it and maybe put it in different levels of decision making, that we start with the most necessary one. And I think that is really indeed a good exercise to practice maybe as a synergy between different projects who are tackling and utilizing IFC for circularity.
Any more questions, suggestions, remarks? Yeah, feel free.
I will keep providing the outsider viewpoint. For the last point that you mentioned, so who should provide all this data, who should fill all these ontologies? I'm sure that you are trying artificial intelligence, so you train a classifier with 1,000 photos of beams, and then it will be able not to gather. So I guess that is one first part of the answer. Then artificial intelligence works 99% of the time, but that's not a lot. If you are in construction, I guess you need many more decimals after that. So probably a human intervention at some point.
That's of course a very good question. As I said, it's also a challenge. What we are at least doing, I can give you an example from REINCARNATE project. We defined this ontology, and for the case of recycling flat glass, we looked into their existing procedures. So basically, they also scan the building, and then they enrich the 3D scan with data. And what we said that we can exercise is that if this structure of enrichment is also based on the IFC, then basically we can maybe develop these procedures that from the 3D scan, once the model is enriched, and most of the time it's at the moment with the expert opinion, but there are technologies that at least it makes it easier for them to assess. Then basically the data that is provided there can be transferred to IFC. So we are using also this procedure as kind of data interoperability, but of course, as you mentioned, artificial intelligence is one. but it's also a hot topic that everyone talks about it, and yet it needs to be developed, right? But that could be also based on similarities such as, I don't know, year of construction, and maybe from images, basically you can maybe automatically fill some of the data and then enrich it with more data, which requires expert assessment.
Yeah, this is this is probably the other, I mean, a different side from what I don't know. 3D scans are, how to say, they produce high quality data. They are made with specific equipment and so on. The AI side is an app on your photo, on your phone, taking a blurry photo, but because you have millions of other photos, even if they are individually low quality, and I'm sure that you have plenty of those photos, then maybe that can do something faster than a special equipment can do, even if with a low quality.
Yeah, sure. I mean, of course, that also depends on how rich your database is. But of course, yeah, it's also something which being really developed. So it's I think in near future we will see a lot of developments on that side.
The AI side is done. You need
data for that. Yeah, for the training. Yeah.
Okay, thank you. This reminds me a bit of all the presentations that we do every Friday at our office. Then we start to present and discuss. At a certain moment, we want to continue, but then we go to the bar. I think it's a bit early now, but there is a coffee break scheduled. It's not too early. Oh. That's true. Somewhere in the world, it's 5 o'clock. You're right on that. No, but I think it's good to slowly move to the coffee break. I want to conclude by saying a couple of words. I was very pleased to see a lot of similarities, but also things that are really adding up. And like suggested by Smart Building, is there something that we even can create practical things to even synergize more on that? Compliments to Sustainable Places, because that's what I experience every year. Before, of course, you prepare your presentation, but we always go back with a lot of inspiration, opportunities and talks. So let this not be the end of the workshop, but I would say the start of a good collaboration, not only within the project, but only within this workshop, but also with other workshops that you will see here. The title was Data Management. Maybe it's a bit strange hearing from me, because as Sam said, I'm the director of a company called Demo Consultants in the Netherlands. We are specialized in real estate information management. So it is actually our core business, data management and information management. But I always stress also internally, it's just a mean. It never is the objective. But if you want to focus on circularity or whatever processes related to real estate, it is a key constraint. Without this fundament, and Elma said as well, I did do it before, but then in a manual way, etc., it's costing too much time, you're missing opportunities, etc. And I think especially in this modern era, there are so many, and we can have a large debate about AI, is it helpful or not, but I think there's a lot going on that really could optimize and therefore could bring us new solutions and new opportunities. So I would like to thank not only the presenters for giving their presentation, but of course also preparing it, but also, I don't know if they exist, the online audience, but I do know for sure that there is a physical audience. So, and well, to be honest, normally at my presentations, on the end, there are way less people than in the beginning. Here it's completely around. So I think you all did a great job. Thank you.